fifth root of 15. We do not need to worry about like absolute values when we have an odd root in the problem. So we only really worry about that whole plus or minus thing when we have an even root. So this one becomes easier. So when I do what matters most, I can look at the largest exponent. In that numerator, we did kind of use FEPL to figure out what we picked. The x cubed is a polynomial or power function. The log one is, of course, a log. So when we have a p versus an L, we can kind of figure out which one matters most in that case. So in looking at this problem, this one does simplify to be the limit as x goes to negative infinity. We have the fifth root of x to the 15th over x cubed. If you can't remember how to do the fifth root of x to the 15th, the easiest way I think about it is a fifth root is the same thing as to the 1/5 power. So power to a power you multiply. 15 over 5 is going to give you x cubed. This denominator has an x cubed. I'll use an arrow there instead. And then this would just give you a 1. So again, we didn't have to worry about the negative since this was an odd root type problem. If this had been like a square root, a fourth root, sixth root, then we would have had to worry about an absolute value in the problem. I will say when it comes to a question on your tests, obviously I'm kind of testing your knowledge and your skills. You're way more likely to see the first question on your test or one like it than that second one. The third problem that I often see mistakes on, this question was, so BC moves a little bit faster. This is a question that was on one of my versions for my BC test. So y'all kind of had the benefit, so whatever BC mistakes made, I can show you so you don't make the same mistakes. This is the limit as x goes to 3 from the left, and we have this function. If you were seeing this problem in your test for the first time, what would be the first thing you would try to do?
Plug it in.
Plug it in. That should be what you always do no matter what, because even though if the problem looks ugly, you want to hope that plugging in works. Well, this one, when you plug it in, you have 3 squared minus, it's going to be 12 plus 3, which is going to give you 0, and then 2 times 3 minus 6 is also 0. So we get 0 over 0, so we do need to try to do something. What would you try to do in this problem so that you could eventually solve it?
Factor the top.
Factor the top. And technically, you probably factor the bottom as well. But factoring the top, so we have this x and x, minus 3 and minus 1. And I'm actually just going to, the order doesn't matter, but I know where this is headed, so I'm going to kind of flip those around for the sake of explaining it. So you do want to factor it. This denominator also factors. And so when you're looking at this, you see something could possibly cancel. You could see that you want those x minus 3s to cancel. You kind of tell yourself, man, I really wish those x minus 3s could cancel. But they technically can't cancel as they're written right now. Why can't you cancel them out right now?
Absolute value.
The absolute value. But we can kind of break it down. So I'm going to focus on the part that we do like, because that's going to be what's left over. So with what's left over, we have this absolute value of 3 minus 1 all over 2. Like that is perfectly okay to use. This second piece, we do need to kind of think about what's happening to it. And it goes back to similar to that first problem we did. So like if you could plug in 3, you are having 0 over 0. But we want to think about when this cancels, is it going to be a positive or a negative number? So we're coming at the limit as x goes to 3 from the left. So if it helps you, just think of a number immediately to the left of 3. So I might think in my head something like, I don't know, 2.9. If this had been the limit as x goes to 3 from the right, I would kind of think in my head 3.1. So in my numerator, I have this 2.9, we're kind of imagining, minus 3. But it's an absolute value, so it's always going to be a positive number. Whereas in this denominator, we have just 2.9 minus 3, which is going to end up being a negative number. Well, if we have the same thing over the same thing, it cancels out to be a 1. But since 1 is positive and 1 is negative, what is it actually going to cancel out to be?
Negative.
-1. So it's going to be times the -1, and then we can finish this problem out. I have 3 minus 1, which is 2. 2 over 2 is 1, and 1 times -1 gives us a -1. So I basically simplified all that to give me this answer. You could do a similar process if I switched this problem and said, what's the limit as x goes to 3 from the right? It would eventually be +1, again, because of the signs for that highlighted part would be positive over a positive. So those are like the tricky examples for limits. Before I kind of give you the last bit of instructions today, are there any questions on any of those three? Yes, Mitchell? I think you're on mute, Mitchell.
Hello?
Oh, there
Hello?
you go.
Can you hear me?
Yes, go ahead.
Okay. Yeah, my mic has issues sometimes. Anyway, so let's say that x goes to 3 and it comes together, like there's no minus sign there. Would we have to do the 2.9 or maybe the 3.1 when it's just x goes to 3?
That's actually a really good question. So I'm going to make up that problem. What Mitchell asked is, well, what happens if we just had as x goes to 3? To be clear, that's what you're asking?
Yeah, that's it.
So if x was just going to 3, this is kind of a unique one since you can't really cancel it out. You would actually have to like first do it from the left and then do it from the right, kind of if it was like a piecewise function. However, you'll see when you go to the left, your answer ends up being -1. And if you go to the right, the answer ends up being +1. So since the limit is going to two different numbers, the limit overall would, of course, be D and E because you have a jump in the graph there. And that's not, if I would ask you one where I want you to test both sides, it's going to often be more of a piecewise question, kind of like the end of the questions you see on homework number 5 would be some good ones to look at. But that's a good reminder of if you can't cancel, then you can look at kind of it from the left and the right to see if you get the same number. Does that make sense?
So this is if there's a absolute value.
Yes, that's the only time that would really happen where you couldn't cancel.
Okay.
So at this point, guys, like I do want to give you plenty of class time to work on everything that you do need to work on. So I, again, am not ending this meeting. Like I will stay in this meeting till the end of class, but this was the checklist I shared with you yesterday. I went ahead and checked the first 3 off because I am hoping that since those topics were on the quiz, like you already completed those. I think most of you did based off of the grade book. But all of this is due by the day of your test, which is Friday. So you have the rest of the day today to continue working on it, the rest of the day tomorrow to work on it, and I guess any time before your test on Friday to work on it. So remember your homework, after the quiz, you only have 2 homeworks I've assigned. You have the limits intuitively and then the continuity homework. I recommend doing all of the problems for continuity, but again, if you just do half of them, that's really all that I am requiring. And I think one day I might have said do the evens when I'm in the odds, but we'll just say for homework 5, if you do half the problems, then I'll give you full credit. But again, I do recommend doing all of them if you have time, but I do know we all have busy schedules right now. And then you have the briefcase binder again, which is part of your summative assessment. It's designed to kind of force you to review. And again, there's 4 parts to it. I would definitely try to knock out at least one of those parts today. I know many of you, I saw it like refresh that you have started quiz corrections, which is great. The quick reference is also something you can knock out early if you're just wanting something really short to do. The unit summary, if you do a good job on it, might take a little bit more time. And then the review questions, there's only 7 of them, and they're multiple choice. But again, all of this does need to be done by the time you take your test. Officially, I won't look at it until 2 p.m. the day of your test on Friday. But I guess you really won't be working on it during your test. So at this point, like if you're good to go, then like, bye, I'll see you tomorrow. But also feel free to hang out and ask questions